Hello everyone. Good evening, one and all. Welcome to the session. Welcome everybody. Can anybody confirm about audio and video, please? Good evening, Sri Sweta. How are you? All right. Clear? Okay, fine. That's good. So, in the last session, I tried to explain one very good question on transformer, the transformer efficiency and losses. So, he has given some information at 50 hertz rated voltage, and he has given some other information at rated voltage and 35 hertz. So, if the frequency of operation changes, how the iron loss are going to be changes, we did, and from that we calculated even the efficiency also. Now in this session, today's session, we'll be taking some question on induction motor. That is, most of the times the questions will be asked on torque slip characteristics. Okay, so at what amount of current you will get maximum torque, or otherwise what is the current corresponding to maximum torque, what is the full load torque. So they will be asking you to calculate full load torque, they will be asking you to calculate maximum torque, they will be asking you to calculate starting torque, and the corresponding currents also, the current corresponding to maximum torque, the current corresponding to starting torque. Okay, and along with this one, like if you remember the torque slip characteristics of induction motor, at what value of resistance the maximum torque is going to be occur. Okay, so there is a condition now, the maximum torque is going to take place at this slip value. Now at this slip, the slip times reactance will be equals to rotor resistance. Okay, if you are expecting same amount of maximum torque at starting, if you are expecting same amount of torque or the maximum amount of torque at starting, what is the value of resistance you must keep? What is the value of resistance we must add into the rotor circuit to get maximum torque at starting itself? So this kind of questions every year maybe they'll be asking full load torque, they'll be asking any one of this, or sometimes what value of extra resistance to be placed in the rotor circuit to get maximum torque at starting. So this kind of questions. So these are four models are there, only one equation and four models. So that is why this question is going to be a wonderful question. So please try to practice this question along with me and try to take up. If you get any doubt, you can ask me. Okay. So we'll move on to the session very quickly. All right. So good evening, everyone. Once again, Madhusudan, hi. Chandu, hi. Good evening. Chalo. So before moving on to the session, this is a small introduction about myself. My name is Naveen. I have 11 plus years of experience in teaching. Most of the times I'll be teaching electric circuits, machines, measurements and power systems. I did my master's in electric power systems from JNTU Hyderabad and cracked GATE and State Public Service Commission examinations too. I taught more than 20,000 students since 2012. So this is a small introduction about myself. So let's quickly move on to the session. Okay, there is a small point to say, that is Telegram channel. So please try to join on this Telegram channel for the announcements or updates, or if you want any doubt clarification, you can join and ask me in this Telegram channel. Okay, if you want any material also, I'll try to post in this Telegram channel. Okay. And if any one of you or if any one of your friends have qualified UPSC Engineering Service Mains examination, BYJU'S exam prep is planning interviews. Okay, mock interviews. Mock interviews are planning, so please inform them to take up the mock interviews so that it will help them to crack the interview. Sanjay sir and Rakesh sir will be taking probably, and from mechanicals, and Chandra sir, Abhinav sir will be taking from civil. Okay, different faculty members are there. They are going to take up the mock interviews. Okay, right. So look at the question. Look at this question. రెసిస్టర్ టెక్స్ట్ బుక్స్ యూ నీడ్ టు డౌన్లోడ్, గూగుల్లోకి వెళ్ళి డౌన్లోడ్ చేసుకోవాల్సిందే. ఒకవేళ టెక్స్ట్ బుక్స్ కావాలంటే చెప్పు, నేను నాకు ఒకసారి టెలిగ్రామ్ ఛానల్లో ఆర్ అదర్వైజ్ పర్సనలీ ఇన్ టెలిగ్రామ్ ఛానల్ యూ జస్ట్ రిమైండ్ మీ, ఆర్ అదర్వైజ్ ఆన్ దిస్ నెంబర్ ఆల్సో యూ కెన్ రిమైండ్ మీ. ఈ టెలిగ్రామ్ ఛానల్ నాకు ఒకసారి గుర్తు చేయి, నేను టెక్స్ట్ బుక్స్ లింక్స్ పెడతాను. మ్యాక్సిమం టెక్స్ట్ బుక్స్ నేను అప్లోడ్ చేస్తాను. ఓకే రెసిస్టర్ ఇంతకు నీ పేరేంటో వెబ్సైట్ కావాలా వెబ్సైట్ ఐ డోంట్ నో ఐ హ్యావ్ టెక్స్ట్ బుక్ సో ఐ కెన్ అప్లోడ్ ఇన్ ద టెలిగ్రామ్ ఛానల్ టెలిగ్రామ్ లింక్ better you search in you can catch me on this number telegram link you can search it as Naveen underscore GOLAPALLY underscore electrical. This is the telegram. You can search like this Naveen underscore GOLAPALLY underscore electrical. So you'll get it probably. If not, you can reach me on the above contact number. No issues. Okay. Chalo. So I have a question like this. A 3-phase star connected 400 volts 50 Hz 4-pole induction motor has a following constants in ohms referred to stator. Okay. So there will be stator winding resistance and reactance, rotor winding resistance and reactance. So all the parameters are referred to stator in ohms. R1 is a stator resistance, X1 is a stator reactance, leakage reactance. X2 dash is rotor leakage reactance, which is referred to the stator side, and R2 dash is the rotor resistance, which is referred to the stator side. And this is a magnetizing reactance, which he has given it as around 28.5 ohms. So all are given in ohms. Okay, all right. All are given in ohms. Now what is asking? He's asking compute the full load torque. Compute the full load torque when the motor is operated at rated voltage and frequency. Rated voltage and rated frequency at a rated speed of 1440 rpm. Okay, he's asking to calculate full load torque. And he has given information rated speed. Rated speed means full load speed only. Full load speed only. So he said that it is operating at rated voltage. Okay. So how do you calculate full load torque? Right. So if we know the equation, basic equation, the power developed by the any rotating machine is equals to torque into omega. Now how can I write torque? Torque can be written as P by omega. Power developed by the motor into omega. So generally the torque production, electromagnetic torque production is proportional to the input power applied to the motor. Input power applied to the motor. So generally if you solve this equation, probably you will be getting this one. The input power I can write it as electromagnetic torque is proportional to input power I can write it as 3 times the current drawn by the motor square into R2 dash by S. Into R2 dash by S. This is the power supplied. This is the power supplied to the machine. This is the power supplied to the machine. Approximate torque equation divided by speed. Divided by speed. At what speed it is rotating? If it is rotating at rated speed, you will get rated torque. If it is rotating at half rated speed, you will get half rated torque. So corresponding speed you can substitute. So I am just trying to derive the torque equation. So please try to concentrate on this one. So the torque, electromagnetic torque, is equals to 3 by omega into current square into R2 dash by S. Okay. So here I2, current I2, the rotor current I2 can be written as voltage, rotor voltage divided by rotor impedance. So I can write rotor voltage as S into E2 divided by rotor impedance as R2 square plus S times X2 whole square. Okay, I can write it as under root. So this is the total current square into R2 dash by S. Okay, so if you solve this one, you will get some information. Okay, but the point is here, all these parameters are referred to stator side. So if you refer to stator side, let me show you how will be the equivalent circuit. This is the stator resistance and this is the stator reactance, and here you will be having the magnetizing reactance, and here you will be having R2 dash by S, and here you will be having X2 dash. So this is, you can have if you want to place external resistance, you can have slip rings area, but for time being I am making it as short circuit. So this is the supply voltage which is applied onto the stator. You can take up, I have taken per phase diagram. So the stator voltage will be, you can take up it as per phase voltage. What is the voltage, per phase voltage? If it is star connected, this is a line voltage, na? So per phase voltage will be 400 by root 3. Per phase voltage will be 400 by root 3. What are the values of R1, X1? R1 value is given it as 0.15, X1 value is given it as 0.45. So let me substitute here 0.15 ohms, J 0.45 ohms here. What is R2 dash? R2 dash he has given it as R2 dash he has given it as 0.12 and X2 dash 0.45. So this is 0.12 divided by slip and this is J 0.45. Now the point is here, so this induction motor, this is a rotor equivalent, na? This is a rotor. So this is a rotor equivalent. On the rotor, I have a, of course, on the shaft I will be having a rotor and on the shaft we will be having the load. He is saying that the load on the rotor is full load. Now if the load on the rotor is full load, then definitely this rotor, the current circulation through this path will be full load current. And definitely this slip will be full load slip. Okay. So if you are able to find full load slip, if you are able to find full load current, now I can get easily the full load torque. I can get easily the full load torque. No need to solve this equation also. No need to solve this equation. You just substitute full load current, you just substitute full load slip. You'll get the answer. Okay. All right. So, but what I wanted to say is, after solving this equation, this term is actually, be careful. This is the speed corresponding to the load. Be careful. This omega should be substituted speed corresponding to the particular load. Speed corresponding to the particular load. Okay. So that point you should keep it in mind. Now, how will you do this? So I need to calculate slip. I need to calculate the current. Can you calculate current and can you calculate slip? Full load slip will be ns minus nr or full load speed divided by ns. Can you tell me what is the synchronous speed? The synchronous speed is equals to 120 f by p. 120 f by p. How much you will get? 120 into 50 divided by 4, you will get it as 1500. What is the NR speed? The rotor speed at full load the full load torque condition is 1440. Now can you tell me how much it is? 1500 minus 1440 divided by 1500. So how much full load slip you will get? 4%. 60 divided by 1500, you will get 4% or otherwise 0.04. So this is the full load speed. Now you can calculate full load current. How do you calculate full load current? To calculate this current, first of all, this entire circuit has to be solved. He has given this XM value as around 28.5, J 28.5. So if you want to find out the current in this rotor circuit path, we will be converting this stator equivalent circuit into Thevenin's equivalent circuit. We will be converting the stator equivalent circuit into Thevenin's equivalent circuit. So you can calculate the Thevenin's equivalent voltage, you can calculate the Thevenin's impedance. Now can you tell me what is the Thevenin's equivalent voltage here? I want voltage across these terms, these terminals. It is simply like voltage across 28.5 ohms. J 28.5 ohms. So supply voltage into this reactance divided by total impedance. Supply voltage is 400 by root 3 into reactance, that is J 28.5, divided by total impedance, that is 0.15 plus J 0.45 plus 28.5. So this is the Thevenin's voltage you are going to get. And similarly, you can solve for Thevenin's impedance. If you solve Thevenin's impedance, if you look from these two terminals, short the voltage and calculate. So JXM is in parallel with R1 plus JX1. R1 plus jx1. Okay. So how do you get this one? J28.5 into R1 plus jx1, that is 0.15 plus j0.45, divided by J28.5 plus 0.15 plus j0.45. This is a ZTH. Now after getting this ZTH and VTH, now what we will be doing is, just let me add one extra page here. Just give me a moment. Okay. So after getting this Thevenin's voltage and Thevenin's impedance, there is the next question actually. He is asking maximum torque and slip corresponding to maximum torque. Now we will be representing the Thevenin's voltage, Thevenin's impedance, which will be having R and reactance. Okay. Now after that, whatever the rotor circuit equivalent is there, the rotor circuit equivalent R2 dash by S, X2 dash, and this is a short circuit. Now you can calculate full load current, you can calculate starting current, you can calculate current corresponding to maximum torque. Because the Thevenin's voltage, once you got Thevenin's voltage, Thevenin's impedance, you can calculate any value of current. But the only thing is, if you want to calculate full load current, you substitute full load slip. If you want full load current, substitute full load slip. If you want starting current, substitute starting slip. If you want maximum current corresponding to maximum torque, then substitute the slip corresponding to maximum torque. So likewise, you can do that. Slip at starting will be anyhow, it is 1. Now slip at maximum torque, slip at full load torque we have seen already. Okay. So if you substitute here full load slip, what will you get? These values are known to you from the calculation ZTH and VTH. From the calculations you'll get a value. Okay. So from here the full load current will be taken as VTH divided by RTH plus R2 dash by S full load whole square, real terms plus imaginary terms, plus XTH plus X2 dash whole square. Of course, if you want to get a magnitude of the current, you take the root of the real term and imaginary term. Once you get the full load current, then you can substitute in the torque equation. So the electromagnetic torque is generally proportional to the input power. So 3 times I square into R2 dash by S. This is the power input. Okay. If you want torque, torque is equals to power by omega. You divide with speed. What is the speed? 2 pi n r by 60. 2 pi n r by 60. 2 pi n r by 60. This is the speed. Which current you are substituting? Full load current. So that you substitute full load slip. Full load speed. So that you will get full load torque. If he is asking starting current, you substitute starting torque, then substitute starting current. The speed corresponding to, anyhow the speed you will not get, but be careful whenever you are solving the equation. Okay. Alright, I'll try to plan for TS Gen call, so no issues. Okay. So whenever he is asking the full load torques or full load currents, so please go ahead with simply this equivalent circuit. So in this equivalent circuit, you can calculate whatever the currents you want. You substitute starting slip, you will get starting current. You substitute slip corresponding to maximum torque, you will get current corresponding to maximum torque. After getting these currents, you substitute in the torque equations. That's it. How do you solve slip corresponding to maximum torque? Slip corresponding to maximum torque is R2 divided by X2. R2 dash divided by X2 dash. R2 dash I know 0.12. Okay, divided by X2 dash 0.45. So you'll get the slip corresponding to maximum torque. Then substitute the slip in the rotor speed. So ns of 1 minus esm, you'll get this as slip corresponding to maximum torque. Okay. So likewise, if you do it, then definitely you will get the answer. The only thing why I am not doing is because of so many here complex calculations. So I am just giving you an idea. This complex calculations you need to have a definitely the scientific calculator. Otherwise, if you don't have a scientific calculator, the point you need to do is the how you are going to do this one. You need to multiply this one. You need to multiply this component. You need to add up this component. They'll not ask multiple questions. They'll ask only one question because it is complex calculations. So definitely they'll ask only one question. They'll not ask you to solve every time because it takes long time. Okay. So once you get these values, please substitute in this formula. You'll get current, you'll get slip, and you'll get torque. Got it? So that is in the same way starting torque also. The same way the resistance corresponding to maximum torque at starting. Here, let me draw the graph. The normal torque slip characteristics will be like this now. He is expecting maximum torque, the same maximum torque at starting. So, if he is expecting same maximum torque at starting, the graph will be like this. So, how much amount of resistance you need to add to get maximum torque at starting? Generally, the slip corresponding to maximum torque is R2 divided by X2. Okay, right. I want to get maximum torque at starting itself. So slip at starting will be 1. How much amount of resistance you need to add? R2 plus Rx divided by X2. So from this you can calculate the external resistance is equals to X2 minus R2. So this total value must be equals to reactance now. So X2 minus R2, if you do that, 0.45 minus 0.12, you will get it as 0.33. This is the extra amount of resistance you need to add in the rotor circuit to get maximum torque at starting itself. Okay. Harihara Sudana, oh, okay. There is okay, I'll tell you. You want air gap power, all those things, right? Okay. The equivalent circuit looks like this. R2 dash and X2 dash. Okay, right. So instead of writing R2 dash by S, we will write that R2 dash by S term as R2 dash plus like this. R2 dash of 1 by S minus 1. Na? If you add this resistance term and this resistance term, you will get R2 dash by S only. Okay. Now, the input power applied, the input power received by the rotor is going to be simply, the rotor input power is going to be received by simply 3 times the current square, rotor current square into active power component is what? If you add up these two, R2 dash by S. So this is the power received by the rotor component. Yeah, you can call it as rotor input or otherwise air gap power. Now, if you take up the power which is available at this quantity, that is called gross mechanical power. So gross mechanical power will be 3 times IR square into R2 dash of 1 by S minus 1. So this is the gross mechanical power. If you want only copper losses, then 3 times IR square into just R2 dash. So this resistance term will give you the copper loss representation. Chandu, which is proportional to constant? No. I said here, generally, whenever you are solving this input power. So we will be substituting here. I'm taking the rotor, rotor speed, and I've explained this one, right? Okay. Okay. So here he has given all the parameters to stator side. So I took what I took, all the equivalent circuit only I have took. Then I started solving the full load current. Now you substitute this full load current equation in the torque equation. What is the torque equation? Power is equals to torque into omega. Torque is equals to power by omega. So this power you can take up it as the power supplied. Power supplied. So you can write it as 3 times I square into R2 dash by S. If you want the power received by the machine. What is that? Rotor component. This current we are substituting. This is if you want full load current, we are substituting full load. If you want full load torque, we are substituting full load current. No, we did not neglect the stator. We did not neglect the stator losses. Sorry, we did not neglect the stator parameters. We considered stator parameters. Then only we have calculated this current. No. Then only we have calculated the current. No. No. We considered the stator current and then we did. Okay, here you are saying R2 dash by S. Here you are saying. That is what, if you include R2 dash by S term, then I will get the rotor, the torque developed in the rotor only. Because you need to consider the rotor parameters only. If you consider R2 dash by S, if you consider this term, if you consider R2 dash of 1 by S minus 1, then what is this power component? This is the gross power. By considering the current corresponding to the gross power. I am trying to calculate the torques which are developed in the rotor circuit only. With the help of current taken by considering all the stator parameters. Torque developed in the rotor circuit only we are finding. Any doubts here? Got it? So that is how you have to do the questions. Okay. Right. So there is a scholarship test announcement. If you attempt the scholarship test, there will be a 90% discount on the GATE actual course fees. There is a workshop also. The workshop is about preparation strategy for GATE 2024, and the workshop will be conducted on 27 September at 7:30. Okay, so try to attempt this one. I think you will get some inputs to crack the GATE examination. There is a crash course which is going on for EE, ECE and the mechanical CSE. So if you want to join, you can join on the crash course to strengthen your fundamentals and concepts. Okay. So this is my Telegram channel once again. If you want to join, you can join here and you can ask me the PDFs of the different subjects, textbooks. Okay. Slip at maximum torque. That's what slip at maximum torque SM is equals to R2 divided by X2. Na? R2 we have already known, 0.12 divided by 0.45. This is the slip at maximum torque. You'll get it. Solve this. 0.12 divided by 0.45. I'm getting around 0.266. This is the slip at maximum torque. Now substitute this slip in the substitute and you'll get the rotor speed. This is the speed corresponding to maximum torque. 1500 of 1 minus 0.266. 1500 of 1 minus 0.266. I'm getting around speed corresponding to maximum torque is 1100 RPM. Hi, Achmay, how are you? On case. After a long time. Where are you? What are you doing? Sure, resistor, I'll send you the books. You just remind me. Just remind me. I'll send you the books. Okay. So, coming to the BYJU'S exam prep platform, try to hit the like button, subscribe, hit the bell button also so that you will get notifications about upcoming classes, announcements, any announcements about job notification, all those things. Okay. Stay tuned with the BYJU'S exam prep platform. Thank you. It is not showing, huh? Okay. I have to search them. Telegram link. If you have any general questions, you can ask me now. Generally, in the class link also there will be Telegram link, no? Description. In the description, I think you can find out. But anyhow, so that is why that's my Telegram link. You can join. All right. So if you have any questions, you can ask me, or any general doubts also you can ask me. Otherwise, we can wind up this session. Any doubts? You can reach out to me on this mail ID also. naveen.gollapalli@byju's.com, or otherwise you can reach out on this mobile number also, 953993. Okay, that's it. Please take more questions, huh? I will take more questions, but in paid class. These are promotions ना my dear Chandu. Promotions के लिए इतना ही होगा. I will take up, but previous year series will be there, na? That I'll plan previous year question series so that I can take more number of questions. At least on 1 hour, at least one question. Sorry, six question, or in 1 hour at least 6 to 7 questions I can plan. Previous year question series I'll plan. All right. Description లో BYJU'S లింక్ ఉందా? ఓకే, డన్. ఓకే, BYJU'S లింక్ ఉందా? నా లింక్ లేదా? సరే, ఓకే. Okay, no problem. I posted in the chat box, so please you can just ask me, just remind me, I'll send you immediately. Chalo then, thank you so much. Have a nice day. See you. Excellent answer. దేనికి excellent answer? క్వశ్చన్లు ఎక్కువ తీసుకోమన్నందుక? Okay, see, this is open, yeah. This is open, so it is like promotions. So we are doing this one. If you like our teaching, please come and join with the BYJU'S. Take some paid courses, so that we will also get something. Right. Okay. Chalo. Kane sir, I think he'll be taking, maybe, I think he's busy with the Vinayak Chavati Puja, I think so. Maybe he visited some temple, I think so. He will take as soon as possible, I think. I don't have an idea, but exact idea I don't have, but because the formalities has to be finished, na. At least it will take 2 to 3 days. I think by this time, I think he might have finished all the things. He might have set up all the things. Maybe Sunday to Sunday हो जाएगा. Sunday से हर दिन fun day हो जाएगा. Okay. Enjoy. Okay, okay. Maybe. నేను నా చాట్ బాక్స్ లో నేను పోస్ట్ చేసినబ్బా రెజిస్టర్. చాట్ బాక్స్ లో నేను పోస్ట్ చేసిన కదా. నేనే పోస్ట్ చేసిన చూడండి ఒకసారి. జిఎన్ అని పోస్ట్ చేసిన చూడు. నీ మెసేజ్లన్నీ రీట్రేస్ అయిపోతున్నాయి ఎందుకు ఎవరు డిలీట్ చేస్తున్నా? నువ్వా ఇంకెవరైనా డిలీట్ చేస్తున్నారా? నువ్వు తెలుగులో రాస్తున్నావు అని చెప్పేసి డిలీట్ చేస్తున్నారేమో మా వాళ్ళు వెనకాల. They might be deleting your messages or you are deleting, I don't know. Okay, once again I am posting my link. You see. Enjoy. This is a link. GN. It's the I posted my link with the name GN. Okay. Chalo. Thank you. Thank you so much. Have a nice day. See you. టెలిగ్రామ్ లో సెర్చ్ లో వస్తుందా? నా కమెంట్ కనబడతలేదా మీకు? మీరే డిలీట్ చేశారా? పైనే ఉంది నాట్ పోస్టెడ్ యువర్ లింక్ కింద ఆన్సర్ ఉంది. నా పోస్ట్ ఉంది. జిఎన్ అనే దాంతో పోస్ట్ చేసిన. మొత్తానికి నువ్వు నాతో రాపిస్తాను అయ్యాల నువ్వు దిద్దిపిస్తున్నావు. https:// దిస్ ఇస్ కామన్ నా t.me naveen _golapally_electrical. Click on that. All right. Chalo. Thank you. Achumi, unnava poinava? Achumi, where are you? Achumi, where are you working, my dear, after a long time? Are you from Assam? Gone case. Okay, chalo. Chalo, see you tomorrow. Have a nice day. Thank you.